Hello and welcome. In this video, we will be learning how to set up MicroPython environment onto a NodeMCU development board from scratch. By the end of this video, you should be able to write and load simple programs onto the chip on a Mac environment. We will demonstrate the working of the setup by blinking an LED. Before we begin, let's talk about some prerequisites. This video assumes basic familiarity with some things. You do not need to be an expert, but you should be familiar with programming in the Python language, the Linux command line, and you will also need to be familiar with simple electronic components like resistors, capacitors, LEDs, and how to assemble simple circuits using these components on a breadboard. One of the first things you need when starting with the NodeMCU is a good quality USB to micro USB cable. Now note that these cables can be of two types. They can be a data enabled cable or a charging only cable. The charging only variety of cables are only able to supply power and cannot transfer data. If you want to program NodeESP from your laptop, the cable needs to be able to transfer data. I made the mistake of using a generic USB charging cable and my computer would not detect the NodeMCU board. I spent several hours debugging that. Then I searched online and discovered that I needed to use a data enabled USB cable. So please make sure you buy a cable that can actually transfer the data. With these requirements out of the way, let us learn a little bit about the ESP8266 chip and the NodeMCU board. Well, first of all, you can buy the NodeMCU board from any standard electronic parts supplier. On Amazon, it is available for about $5 and usually comes for $15 in a pack of 3. This is a lot of functionality for $5 and a great tool for learning the basics and exploring. The price point of $5 also lets you explore if you like doing microcontroller programming before committing to next level platforms like Raspberry Pi or Arduino. These other platforms, next level platforms, have a price point of about $50, and depending on your price point, you may feel more or less comfortable experimenting with them. Before jumping to the setup, let us learn briefly about the ESP chip and the NodeMCU board. The ESP chip itself is shown on the left side. It was introduced in 2014. The chip itself consists of general purpose input-output pins, by which I mean that the voltage on the input-output pins can be set up using code. So you can switch the value of any pin using to 1 or 0 using Python code. Then there are special purpose pins available on the ESP, which include pulse width modulation, analog to digital conversion, and the ability to connect to Wi-Fi to communicate data in and out over the internet. We will be learning a lot more about these capabilities in the next video in the series. A lot of interesting projects can be done with these functionalities. Now, note that ESP8266 shown on the left is a bare chip without an easy way to connect to the outside world. A bare chip like this would be pretty hard to program. It needs several accessories and peripheral devices like a USB connector, a converter from the USB to the serial format, and so on. For now, just remember that ESP8266 is the processor and the NodeMCU board is ESP8266 plus the accessories that make it easier to connect to a computer and program. So on the right side, we are showing the NodeMCU board where the ESP8266 chip is a part of that board, but that board also has several different accessories that are required to make it easy to program the chip. In this tutorial, when we mention the ESP chip, it almost always refers to the NodeMCU board. Alright, so let's look at the structure of the NodeMCU board again. So here is the NodeMCU board with important components highlighted with a red boundary line. On the left is the ESP8266 chip. In the middle is the AM1117 voltage regulator, which brings down the voltage from 5 volts to 3.3 volts, which is the operating voltage of the chip. And on the right side is the CP2102 USB to UART converter. UART stands for Universal Asynchronous Receiver Transmitter, and it is a form of a serial communication protocol. If you don't exactly understand what this means, don't worry, because we will be providing the exact instructions for programming the chip, and it will all become clear as you start playing around more with the chip. The ESP needs to be programmed in the serial mode, which means the instructions need to be sent to it one bit at a time. However, recent laptops usually only have USB ports. The older laptop used to have RS-232 ports and other serial ports, but nowadays laptops almost exclusively have only the USB port. So a USB to serial converter is needed for converting the USB output from the laptop to the serial input for the ESP. This converter is built into the NodeMCU board, and that is precisely what Silicon Labs CP2102 is. To get your laptop to recognize the chip, you need to install a driver which depends on the vendor of the USB to serial converter chip. There are multiple vendors, and the board that I have has a USB to UART or a USB to serial converter from SI Labs.